Okay, so this one is actually pretty much the first lab I have any of my students do. It's less focused on physics and more about collecting data and understanding what you're dealing with. The main thing that I really want to focus on with this, the main thing that I want students to take away from, is the idea of getting repeat measurements or multiple measurements, depending on which one you'd like to emphasize even more. So this one I usually title simply the note card lab, because for me, as part of my classroom procedures, I end up needing a decent number of note cards throughout the semester. I realize I'm probably not looking at the camera because I've got it pointed more at the equipment. So I know that I usually need a bunch of note cards around, so I usually get like 10 or 12 packs of them, giving me between 1,000 and 1,200 note cards each year. And I usually end up, yes, going through most of them, it turns out, but that gives me plenty to work with here at the very beginning. Normally what I do is, for some of the classes before I've done the challenge of, I want them to predict how much a new pack of note cards would be, 100 note cards. And that's why it's nice having a need for 10 different packs, because I pick up those 10, I measure the full packs on here, and then do each of the 10 packs and measure them a couple times each, and make certain that, because they're not all going to be perfectly identical, so I'll take those and I'll take the average of those and give that with a little bit of statistical analysis, some standard deviations, so that I can tell, you know, where my brackets are, to tell them, okay, it weighs exactly this much, and then if you're within, you know, plus or minus 3 grams of that, then you're good. You've actually predicted what it would be. With the AP classes, I've also given them the dimensions of a cabinet, say one of mine in the side of the room or something like that, where it's 1 meter by half a meter by 2 meters tall or something like that, and I have them project how many note cards we could fit on that. Or you could give dimensions of a pallet, so try and tie it to something in real life, where maybe they've been hired by a company that actually produces these, and they want to know how heavy one pallet is, so that of given dimensions, so that they can actually ship these out to the stores that they need to go out to. I also, one of the final things that I did this last year for the AP classes was I gave them a 2,000 pound limit. In other words, I told them instead actually just 1,000 kilograms, about 1 ton, and said that that was the limit for the elevator that we have in the building, and asked them how many note cards they could actually put in the elevator to safely get it to go upstairs without going over the limit. So those are things where you can tie it to something in real life that they might care about. And especially tying it to, hey, you could be hired to do this as a job, is a good thing to do. Okay, now that my babbling is a bit out of the way, so that you have some ideas on scope and ways to connect it, let's talk about the actual nuts and bolts. Now, there's a good bet, hopefully, the supplies that you're going to need, let me start off with that. So that I have listed for my note card measurement one are going to be note card packs, if you opt to go with note cards. Scales, so you're going to need some way that they can actually take weight measurements. I have written down a cabinet, but you can always make one up, or you could give rough dimensions on a pallet. And then I also have an elevator listed. It's nice if you have the time or want, send students over to actually read in the elevator itself to see what the weight limit is. Most likely it'll be in pounds, so if you're using metric, you can also have that as an exercise for them to convert from one unit to another, so whatever you'd like there. Now the main things that you actually need for this, aside from, you know, the usual pen and paper to record data with, is a scale of some kind. If you have the fancier electric scales, then this becomes even easier for you. But the ones that came with my classroom are some of the old balance beam scales that I've got. Now, according to my write-up for this, I tell the students what to do, although with the AP classes I've actually been leaving it more open for them to design their own way of predicting how many note cards they could put in an elevator, that sort of thing, at least until you hit the weight limit. Or, actually, I think this last year I didn't even tell them that they would necessarily hit the weight limit, but they have to find out if they'd be limited in physical space or in actual weight. So for that, the main things that you're probably going to need are scale and note cards. Now, you don't have to use note cards. You could also get like a box of 100 bolts from a hardware store. Should be $10 or less. And then you could have them do the individual bolts. In short, you're looking for something that's mass-produced, but even though they're mass-produced, they won't be physically identical. I can see someone's actually kind of written on this one. You could look into fresh versus ones that have been written on as well. But have them place it on here. And then I gave them some pointers on how to use my equipment, where I line up the needle where it's blocking this O, and it appears to be the sharp point is up on the black line. so that you can kind of reduce parallax. If you do end up using something like this, you want to try and direct the students to be directly in front of it. Set up a chair or something like that. And also tell them not to move it around, because as you adjust the balance on there, it can also throw off some of your measurements. Especially if your table isn't perfectly flat. A number of my lab tables are actually tilted. Well, they're desks, but neither here nor there. You can have them go through, and then these are 5 note cards. I apologize. I have 5, 10, and 20 are in the instructions for them to do. I usually just give them a stack of 20, and then they can count out 5 and then 10, and then make measurements of 20. For my general physics classes, I tell them explicitly that they need to have repeat measurements. So in other words, they need to do 5 cards maybe 3 times, and then 10 cards 3 times, and 20 cards 3 times. But your end goal is to have them come up with a number and then see if it hopefully falls within the range that they need. The big things to focus on this are if they simply take a measurement of 1 note card and multiply it by 100, in fact, have them do that measurement. Or just take the 5, for instance, just one of the 5s, and multiply it by 20 instead. You might get it where it actually works out, although usually the 1 note card by itself won't, because not all the note cards are uniform. And so one of the big things that you really want to emphasize with this is repeat measurements. Now, you can also do a lot of work. I usually take them over and work in Excel too, so I can show them how to get computers to do a lot of the tedious math for them. Take that as you will. But then also generate a graph for things like density of the card. One of the other things that can be useful are rulers to measure the actual physical lengths, so the height and the width of the note card. And then if you don't have a set, I recommend getting some. This is an incredibly laughably cheap one, but it still does the job. These are calipers, and you can go through and you can get the measurement of something very thin with them. Even 1 note card can actually be something that you can measure if you've got a good pair of calipers. These are not actually one of my good pairs because they don't line up quite right. If you're not familiar with it, you can Google the Vernier scale. It's actually a scale, if you'll notice that there's another set of numbers down here, and they don't quite line up. There's a way that you can actually use that to read it. Although this cheaper one that I've got, the scale's a little off. I've got a few others where the scale is actually really good. I could check my notes and see what the thickness of 1 note card is. Or you can also go through and you can take the 5, put them together, measure the thickness of that, and then divide by 5, but I find it a little bit better. Well, again, theory of measurement, do it multiple different ways. The limitation on that is it can take a little bit of effort to teach the students how to read the Vernier scale, so take that as you will. So you can do whatever you'd like with the resultant numbers, but it's kind of set up in a way that if they just rely on the measurement of 1 note card and multiply it by 100, they'll actually pretty much always be outside of the tight range that you can end up with deeper and more specific measurements. And so it's showing the idea of precision and, to a lesser extent, accuracy. And the way that you can get that is by acknowledging that not all these are going to be exactly the same. They're going to be small things that throw off one versus the other, and carry that over to future measurements as well. Because one of the big things that I've noticed, especially in the redesign for AP Physics 1, is you really want to emphasize the nature of taking more than just 1 or 2 sparse data points. You want the students to be thinking, we need a good amount of data for each one, be it different ones, say 1 note card, 5 note cards, 10, 20, 30, that sort of thing. Or even taking, okay, I've got 10, I want to do 3, measure it 3 times, make certain that I didn't mess up on one of them. And so, but this is one of the first labs I do. It should be relatively straightforward, and it's got a lot of versatility where you can play around with it as much as you'd like.